Thanks for watching this video. We're going to talk about specific gravity. And specific gravity is a long word, so we're normally going to abbreviate it as SG. And it is defined as the density of the substance divided by the density of water. And we saw in the last video, right, that water has a density of almost exactly 1 gram per milliliter. And so what this ends up being, well, actually, let's go ahead and do a calculation. Let's say you've got some gold. And we said the density of gold is 19.3 grams per milliliter. We can calculate the specific gravity of gold, and we would just take the density of gold and divide it by the density of water. And that is 19.3 grams per milliliter divided by 1 gram per milliliter. Now, I'm going to play loose and fast with the sig fig rules here. Normally we would say if that only has one significant figure, right, the final answer should have one. But I just wanted to kind of show you what goes on here. And what goes on here that's of interest to us is that if you divide anything by 1, you really don't change the number. And if you look at those grams over milliliters on the bottom, they're also there on the top. And what that means is that the specific gravity is just a number. It is unitless. So it has no units at all. It is just a pure number. So you can see too that it's almost exactly the same as the density, but we've just left off the units. So that's how we calculate specific gravity. It's just the ratio of the density of substance to the density of water. So how do we measure specific gravity? Well, you might think, well, we just measure the density and compare it to water and divide, and Bob's your uncle. But it turns out that we actually have a device called a hydrometer. And here's a picture of a hydrometer from your book. And it's sort of like a thermometer in many ways, except it's got a sort of a lead weight at the bottom. So this is the hydrometer. It normally has a big bulb in the bottom that has a lead weight in, or something with a lot of density. When we place it in a liquid that's very dense, that has a high specific gravity, then it floats a lot more, and so it reads a higher number. And when it's in a liquid with a very low specific gravity, it sinks a lot more, and so it reads a number that is much smaller. So there's actually a sort of a zoom-in region here, and you can see that we basically just read this as a scale. So this would be, I guess, 1.020, and let's see, there's 5 divisions there, so that each one would be 0.002. So we would read this. This is essentially 3/5 of the way down. So this would be 1.026, the specific gravity. And notice it is completely unitless, so it has no units whatsoever. So it's just a raw number. So that's a hydrometer. We often use it when we make beer or wine, because when we dissolve sugar in water, it has a high specific gravity. And as we ferment it, we convert that heavy sugar into light alcohol. Alcohol's got a density about 2/3 that of sugar. And so as we ferment it, the solution becomes less dense. It has a lower specific gravity. It's very easy to measure specific gravity. You can buy a $2 hydrometer, and we can kind of watch how much it's fermented by measuring the change in specific gravity over time. That's a commercial use for it. Now, of course, we can measure specific gravity of urine. And so you can take urine. Urine has dissolved solids in it. And if the specific gravity is very low, that means that essentially you are peeing out water. So your kidneys aren't functioning very well, or you're extremely hydrated, maybe too hydrated. If you are peeing out urine that has a very high specific gravity, you might be dehydrated. So you might be well hydrated here. Or you could have improperly functioning kidneys, so you've got kidney problems. You're basically excreting too much water. If your specific gravity, though, is high, that means that there's a lot of sugar being excreted. So maybe, I can't spell excreted, can I? How do you spell excreted? E-X-C-R-E-T-E-D. So maybe you've got diabetes. So you are excreting too much sugar. Or maybe you are dehydrated. And if you are dehydrated, then you don't have a lot of water to spare, so the fluid that you urinate out has as little water as possible, and that means it's got a lot of dissolved solids. So we've got a range. Let me see if I can pull up a range chart here. So here's a chart here of normal ranges. So if you are specific gravity less than 1.010, then you are well hydrated, and so on. So if it's a little bit higher, then you have slight dehydration, significant dehydration, or if your specific gravity is above 1.030, you're seriously dehydrated. So it's a very nice way to keep track of bodily function, I suppose. I used to work for a drinks company, and we actually used to measure specific gravity of our drink in order to monitor the sugar content of it, actually. So it's a very nice, easy, cheap technique to keep track of things. And that, by the way, is the end of Chapter 1. So thank you very much for watching, and I look forward to seeing you in the next video where we start Chapter 2. Bye-bye.